All right, so hi, my name is Arnaud Dehors. I'm from IBM. I'm part of the Open Technology Group. I'm an open source, open standard specialist. I've done that all my career, which is about 30 years now. And what I want to talk to you about today is the latest project I've been working on, which is Hyperledger Fabric. This has been going on for 3 years now. We essentially launched Hyperledger 3 years ago with the Linux Foundation. One thing that I do want to clarify to get started is there are a lot of people who say, I use Hyperledger. And I always say, how do you use a consortium? Because Hyperledger is not a software, it's a consortium, right? And so that's the first point I want to make quickly. Hyperledger is basically, technically it's called a collaborative project. It's hosted by the Linux Foundation, which has become over the years into what I call like a meta consortium. It's a consortium of consortiums. And so instead of creating a consortium from scratch, you can instead go to the Linux Foundation and create a collaborative project. And they basically have the class consortium, and they can do new consortium for you. And for some money, they manage everything. And so it's much faster and much easier to create a consortium that way. So when IBM started working seriously into blockchain, we started in, obviously we have a lot of people in crypto and research, and so they were looking at that for a long time. But when we started looking into it from a business point of view, we realized, okay, this is the kind of technology, it's peer-to-peer network. You can't have that as a proprietary solution. It has to be open source based. And IBM has a long history in open source. This is actually my 20th year at IBM, and I'm happy to say I've only worked on open source and open standards since then. So this is nothing new for IBM, it's part of our DNA. So in this case, we actually approached the Linux Foundation. They were interested in creating a consortium to host development of blockchain technologies. And so we created Hyperledger. There are actually 5 different blockchain networks today hosted by the Hyperledger project. Okay, so that's why when I say, when people say I use Hyperledger, I'm like, well, what do you use? Because typically people mean Fabric because it's the most prominent, the most popular blockchain network or framework that people use. But if you want to shorten it, because Hyperledger Fabric is kind of long, you can say Fabric. Just don't say Hyperledger because that's too confusing. Okay, I'm not going to get into the details of all of this, but as I said, there are different frameworks, and some of them are really interesting. Sawtooth was actually contributed by Intel, and it has an alternative to proof of work called proof of elapsed time, where they're leveraging secure hardware, which they happen to sell, SGX, but it actually achieves the same result of proof of work without consuming any energy. But there are other projects, and Borrow, for instance, is another one, which is an implementation of the Ethereum virtual machine. So people think that, Hyperledger competes with Ethereum. It's not exactly true. And Hyperledger indeed is a specific framework and a set of libraries. I think there was a presentation this morning from Rich. So it's dedicated to managing self-sovereign identity backed by blockchain. It's very interesting. So, and then there's a bunch of tools as well that kind of builds on those different frameworks. So what is Fabric? And why do you even bother developing Fabric in the first place? It's not like blockchain didn't exist. The problem is a lot of the blockchain frameworks that are out there, they were initially, at least, when we started looking into it, they were really designed as public networks. And when we're looking at it from an enterprise point of view, which of course is IBM's focus, we realized there was a big mismatch between the characteristics that the business networks typically have traditionally and what the blockchain systems that were offered at the time were providing. And so, to highlight some of the key points that led us to say, okay, well, there isn't one that matches the enterprise needs, so we're going to build one. For instance, the first thing is businesses do not function in public. They have relationship and they interact with their peers in a private way. So that's number one. They also want high performance because So you're familiar with the Ethereum and Bitcoin. You're talking about like, on the order of 7 or 10, 15 transactions per second, right? With Fabric, we have over 3,000 transactions per second. And last week, there was actually a guy from Cornell University who presented some modification to Fabric where he multiplied that by 7, 25,000 transactions per second, okay? And so it's quite different. In Ethereum, for instance, they have chosen to try to address security by limiting the programming that you can have in your smart contract. So they have the Ethereum virtual machine that sets a specific number of operations you can have. We made a different choice where we give people access to traditional full-purpose programming languages. Fabric is written in Go, so that's the first language that's available. But you can write your smart contracts in Java as well in Node.js. And I mean, there's essentially a pluggable API, so you could possibly support other languages. And we have no mining. There is no notion of gas, because in the kind of applications we have in businesses are making money by trading some services on some goods. They are not trying to make money out of running the system, right? So in fact, a lot of applications in the business case, when they are working with Ethereum, they turn the gas off. They have to basically, I mean, in a permission way, right? They use because it becomes more of an annoyance. And so we didn't put that in at all. And then maybe the biggest difference of all is the consensus process. It's fundamentally different. One thing we wanted to have is finality. So in Ethereum and Bitcoin, for instance, you have forking going on, and then eventually, the network will converge back and forth. But that means you really never know whether your transaction, even though it has been validated and put into a block, whether it will stick or not, because it might actually be dropped further down the line. And that's why you have to wait several blocks to start feeling confident that your transaction is not going to be dropped. So that's something businesses do not like, and it also affects performance. People typically wait 3 up to 10 blocks depending on how sensitive you are to this process. So we actually broke down the consensus process, and that's what I'm going to talk about next. But we have, I'll talk more into the detail next. So we started in 2016 with the first version of Fabric 1.0. There was actually a pre-version of that, 0.5, 0.6, which we already did. And but so this was the first major release, and we have since then adopted a release cycle where every quarter we have a minor release we're publishing. What's interesting is one of the key aspects of Hyperledger is to enforce certain rules. And we're all about open governance. It's not enough to be open source, like, you have this like GitHub repo, and there's a group of like a company like IBM would, push code on the outside, but they keep control. Hyperledger is about open governance, and IBM is a strong believer in this. We have in many other open source projects be a main actor into opening up the governance of the project. And so you can see, obviously, when we started, this was based on a contribution from IBM. All the contributors initially were IBMers because that's what they were. But we have actually worked very strongly, very hard to open up the project. And you can see that in the latest release, we have almost 300 contributors. A lot of them are not from IBM. I'm not going to lie to you. There's still a major, weight carried by IBM. We probably carry about half of the contributions still on our own, but because we have a strong commitment to this and we're building a business behind this. But I'm happy to say that there are many different organizations that are also contributing. So the architecture, and that's where I'm going to talk a little bit about the consensus process that I was referring to earlier. So this is a high-level kind of picture of the architecture. First, at the top, we have membership services. And so don't get fooled. That doesn't mean it's a server and it's centralized all of a sudden. This thing is like distributed, and you can have several of them for each organization participating in the network. But this is what controls access, because we're in a permission network. Then you have on the left side, obviously, there's a client application. It will use some SDK. There are different SDKs available to interact with the network. Then what we have, which is kind of unique to Fabric, most of the time you have some node that you talk to. And the node interacts with the network and does all of the validation, running smart contracts and all that. In our case, we have actually divided the node into 3 different functions. 2 of them are actually implemented in the same process, which is the one on the right side over there, endorser and committer. And then in the middle, you have the ordering service. What we've realized is that there were really different parts in the consensus process. And the 2 big ones are, there is a part which has to do with ordering the transactions, and it's independent of the nature of the transaction. It's making sure that we all agree on the order in which the transaction happened, because when a peer-to-peer network, transactions flow and come in from any part of the network, and at some point we need to agree on the order. And this is how you, by the way, avoid the double spend. And then there's another part which has to do with validating the transaction in terms of, do I have all the information that I need to make sense of the transactions? And is it valid at this point in time in the logic of the application, right? So quickly, the process flow is the application will submit a proposal to an endorser. This is basically saying, I would like to submit this transaction. The endorser is going to validate that transaction, again, testing those aspects that I just mentioned. That's where it runs the chain code in our case, which is the equivalent of the smart contract. Once the client has gathered enough endorsement, then I'll get more into the detail of what that means, endorsement. It will submit that to the ordering service. Again, this is not a centralized thing, it's a distributed thing, but for the sake of the concept, there's this ordering service. You can see there are 4 nodes there. There can be as many as you want. It actually can use different algorithms to come to consensus on the order of the transaction that have been gathered. It will cast a new block, and it will broadcast the new block to the system. All the peers that receive the blocks will then go through a validation process to make sure that the endorsement under which, the conditions under which all the transactions have been validated in the first place are still true, and then we'll commit that new block to the ledger. Then there's a notification mechanism to inform everybody. So this is basically the process flow. One aspect is that it's final. Again, as I was mentioning, we can catch non-deterministic smart contracts. So because then the endorsement, will differ from one to another. And yeah, I'll just leave it at that. So membership services, I explained. This is, conceptually, it's the service to which you're going to go to get keys, to enroll, and gain access rights into the network, right? There is an implementation. So the system is designed so that there's an interface. You can have multiple different types of implementation. There isn't one implementation that's built in, that's offered, called Fabric CA for certificate authority, that actually plugs into many different existing systems. That's another aspect of Fabric. We call it bring your own identity, because in the enterprise setting especially, most enterprise already have some identity system, if not more. The last thing they want to hear is, oh, if you want to use a blockchain framework, you have to create a whole new set of IDs. So this system actually allows you to do this, to integrate with existing systems. I talked about endorsement policies. Most systems, traditionally blockchain systems, there's this notion of miner that actually does validation, smart contracts that run. in reality, in the business case, there are sometimes regulations even that impose, certain actors in the network to validate transactions. And not everybody necessarily needs to validate all transactions. So what we have actually is a system that allows you to define the policy under which, transactions must be validated. So we have a simple policy language, endorsement policy language, which basically allows you to specify for your channel, for your application, who needs to endorse the transaction for the transaction to be considered valid. So you can see there's an and and or operator. I don't need to get into the detail. I think it's pretty simple and straightforward, but it's enough to allow you to define different policies that fit your needs. And in fact, this is all handled by a specific part of the system that's also pluggable. So if you really fancy another policy language that's much richer, you can also implement this. We have also added a notion of multi-channel, which is pretty unique to Fabric. Because when we started, we said, okay, our business networks, they want to work in private, so we are going to allow them to have this permission network. What we actually quickly realized is that even within a network, there were transactions that they didn't necessarily want everybody to see. So multi-channels basically allows you to further segment the network. So in practice, they're actually different chains, and you can define which participants in the network can see, can access what channel. And that allows you to actually segment the network the way you want, and you can run your smart contracts or chain code in our case on any different channels. Every possible combination is available. In terms of the roadmap, as I said, we have this release schedule where every quarter we have a new release, and we just released version 1.4. We were actually slightly late because we should have released in December, but with the holidays and all, we just released it at the beginning of January, but it's out, and so we're barely just a little bit late. The big thing about this is that it's the first long-term support release. So until now, we were, if you found a bug, you basically were told, yeah, just update to the latest release. Now we're actually committed to support 1.4. That means we actually have switched to 2.0. And so I'm going to give you an idea of what's coming up. There is a lot going on in Hyperledger Fabric. And quite frankly, it's a bit overwhelming if you just want to casually try to understand what's going on. We have gone a long way from, as I said, moving from a proprietary development to an open source with an open governance project. Now the trouble, and I used to, it's part of my role in IBM, is to help the product group transition from proprietary, traditional top-down development to open source. And, I used to complain that they didn't, provide the community enough information about what was going on. And now we have a bit of an excess of the other way around, which is there is so much information available. So I can't blame them anymore because they have done their work and everything is really open. But now there's a huge amount of information. So, what I wanted to give you, and you saw that on the slide before, by the way, you see all these different features that keep being added release after release. What I wanted to give you is an idea of, okay, what are the main axes of development so that you get a better picture of what's going on, and based on your interest, you can look into it. So in terms of privacy and confidentiality, as I said, we have already had several steps where we started with just permission network, then we added channels. We keep going on that way because then there's a notion of private transaction. So a lot of people, they don't want to even put the data into the blockchain. So they want to encrypt the data. They just put the hash on the chain. And then the question is, well, what do you do with the actual data? And so what we have done is we've made it available for you as the application developer to do that automatically. And you can declare certain part of your data to be private. And what happens is that we will actually communicate the private data to the other peers that you decided to give access to. The data will be hashed, and only the hash will be actually stored on the chain, but the actual blob of data will be also communicated directly peer-to-peer. We are going down that way much further. We have now introduced, there's a technology from IBM called Identity Mixer. We're leveraging zero-knowledge proof type of technologies to allow more control over, privacy. In terms of the consensus process, I said it was pluggable. So in the original version of Fabric, we actually had two options. One's called Solo. It's actually not really a consensus process. There's just a server. It's a single node, but it's good for development purposes. And there is Kafka, which is used in production, which is fault tolerant, but it's kind of heavy. So there is development to use Raft, which is another crash fault tolerant system. And then we are moving towards supporting SBFT or PBFT, one of those Byzantine fault-tolerant processes. We have made a lot of effort into improving serviceability. Initially in Fabric, if you wanted to change your chain code, you literally had to shut down the whole network, update, and then restart, which obviously doesn't work very well in production. So all of this becomes much more automatic now. The system is much more resilient. And there is a lot of information that you needed to have out of band that is now available directly from the system. It can be pulled from the chain. We're also improving the programming model API. So Fabric is a very low-level API when it comes to data. It's key value pair. What the key means, what the value means is up to you. For Fabric, they are just bits. So this is a bit hardcore for an application developer. So what we have done now is started to, bring a much higher API, much higher level API, so you can talk about assets and things like this. And then there are other interesting developments. There's one which has to do with being able to support Ethereum virtual machine. So I've talked about Hyperledger Burrow, which was an Ethereum virtual machine implementation that's available in Hyperledger. We support putting the Burrow Ethereum virtual machine as chain code on Fabric network, and we have a Web3 proxy so that you can actually use an Ethereum client that talks to the proxy, and it looks like to the client, it looks like it's talking to the Ethereum network, but it's actually talking to a Fabric network. And on the other side, it's actually executing the Ethereum smart contract, possibly written in Solidity, for instance, on the Fabric network. And there's a new feature called Fab Token, which will allow you to deal with fungible assets in a more efficient way, with a combination, again, of UTXO, if you're familiar with this model, but also zero-knowledge proof for privacy. Quickly, the way you interact as an application developer with the system, there are two main parts that you need to worry about. There's the client side at the top there, and you interact with the network through an SDK, and there are several SDKs available. And there's the smart contract, which is your chain code. You actually don't have to worry too much about the blockchain unless you want to. The API at the chain code level is just, putting data and getting data. All the blockchain-y stuff is actually done for you by the framework. There are many different tutorials you can start from. All of that is available open source. The first thing is bring your first network. There's actually, everything is Dockerized. It's all Docker containers. So there's a script that you can start from. It will pull all the images from the network, and it will get started very quickly. And it will run all of this into your own machine. And then there's application you can start using to develop. One thing that's important to know is it can be complicated to debug, and it's a pain when you get started. So, for instance, the chain code is run as a separate container that's spawned off by the peer itself. So there is a process, you install your chain code and you instantiate it, and then the peer forks this it spawns off the container with which it has a very secure connection. Problem is when you want to debug, it's not very convenient. So there's spatial mode. It's important to know dev mode, where you tell the peer don't do that, and you basically start the container with the chain code yourself. You have access to this, you can shell into it, and then you start your network, and it doesn't spawn off the container. So there are many different APIs. That's one of the goals of Fabric, was to make it extremely flexible, because we don't believe in one solution fit all. And so there are different languages available. What does IBM do with this? Very quickly, we actually don't have our own version of Fabric at all. All our developers are working on Hyperledger on a daily basis. We contribute all our code to Hyperledger. The only thing we do then is we take this and we basically host it on the IBM cloud, and with some tools around it for monitoring, deployment, we actually allow you to develop your application in the IBM cloud. And then finally, I just want to give you some pointers, and I'll make my slides available online. But there are basically two directions you can choose. There is Hyperledger as a bunch of, we publish a whole bunch of documentations and tutorial, but there's also IBM. There's IBM developer website, which has a huge amount of data, code patterns, and things like this that you can use to get started. And the IBM blockchain platform, there's a starter plan which is free to use, so you can get started, get a feel of what it's like. All right, I will stop at this. Thank you. I normally talk 2 hours on this thing, so sorry if it feels a bit.
Any questions?
Can you share a few examples how businesses actually use the platform?
Yes, indeed. So I didn't want to get too much businessy, but yeah, it's a good question. It's like, what kind of applications? We actually, I'm glad to say we have moved on from just proof of concept. We actually have different production systems now. And so just to talk about a couple of them, there is one called TradeLens. It's a platform we have developed with Maersk to manage all the paperwork associated with shipping containers around the world. And so the idea is that when you ship a container from one place to another, there's a huge amount of paperwork that needs to be taken care of. So it will involve different agents throughout the life of the shipment. It starts with, like, the shipper companies, of course, but it's the port authorities, it's insurers, tax authorities, the transporter itself. And so we actually have this platform which allows all these different actors to access the chain and add information associated with the container. It actually it gives a lot more transparency, and but also it's a lot more secure. There's a lot of fraud in this space because people literally copy, they do Xerox of paperwork. And it's a huge hassle, it's a huge cost. There's another one called Food Trust, which we've developed initially with Walmart, but now there are other companies like Carrefour are joining, where we are tracing products. So we can tell you the provenance of the chicken that you're buying in the store, and it helps a lot in dealing with like food contamination situations where they do this recall, where instead of having to, recall huge amount of chickens because there's one farm that got contaminated, we know immediately where all the chickens from that farm are. Okay.
Yeah, I was just wondering, do you think with the amount of development going to Hyperledger, it might be the leading blockchain software in the future? Like, there seems to be a lot of development in it.
It might be the what?
The leading one.
Well, yeah, so, I'm old enough not to believe in one, replacing everybody. I've been around the block for too long. So I wouldn't dare to say that, yeah, of course, everybody's going to just use Hyperledger Fabric and that's it. But I do think there's huge momentum, and there's really not much reason not to use this one, by the way, because Hyperledger, what's interesting to know is you can participate in every activity related to Hyperledger without being a member. Individuals or companies alike are welcome to participate. So,
Yeah, it's a short question. You used word change sets, and and you didn't provide a repository. So how can I compile it? Because I don't know if do you use Git for your work?
GitHub?
Yeah, no,
Yeah.
not GitHub, but Git in general.
Yes,
because
yes,
you
yes.
said change sets, and it said in
A
one file
change
it says-
set.
Yes.
Okay, that I know.
It's
what
from
you-
Jazz. Yes.
Yeah, so two different. So just by the way, we do use GitHub, although we actually use Gerrit, and on GitHub it's just a mirror. So if you want to become a contributor, you have to use Gerrit, but that's a detail. So the change set that I think you're referring to had to do with the. So it's part of the endorsement. When I said, we have to validate at the end when the block comes back from the orderer. What happens is that we don't want to rerun the whole chain code because that can be quite expensive. So what happens in the first step, when the peer actually endorses the transaction, it runs the chain code and it essentially simulates what this transaction wants to do, which means that it's actually not going to modify the actual data. Instead, it actually produces a change set, which is a read-write set. It tells you which variables are changed and from what to what, right? And so the last step at the validation process, after the block has been broadcasted to everybody before it gets committed, what the peers do, the committer part of the peer does, is actually go through the transaction and verify that all the change sets still match the current state. That's how you catch the double spent, so that if I say, okay, I'm giving $1 to Joe, and that same $1 I'm giving it to Bob, only one transaction can be validated. At the time of endorsement, both could be endorsed because every time it says, yeah, it has $1, it can give it to Joe, or it can give it to Bob. And at some point, you need to reconcile this. Once it goes through the ordering and it says, okay, John is before Bob, well, then at the end, you're going to go through this validation, which is a very quick process. It's going to say yes, okay, he has $1, gives it to John, and then the second time it's going to say no, there's no more $. It is like the account is 0 now, so you cannot give it to Bob, and it could be not 0, but even if it was any change, okay, that's what this refers to.
Yes, quickly. So I see from some links on the web that you can run Ethereum smart contracts on Hyperledger Fabric. So which one is the direction that is preferred by Hyperledger Consortium? Because both projects are supported. So is the Fabric going to be the one for the future, and then the Ethereum Fabric is going to be shut down?
So there are two. I can answer this question in two different ways, because so you said Hyperledger Consortium. At the consortium level, we don't have an opinion, okay? And I'm part of the technical steering committee, which is an elected position. Every year, all the contributors can run for the technical steering committee, and there's an election. And so, as a technical steering committee member, I can tell you that we value every project in the same way. And we don't have an opinion. The whole idea of Hyperledger was to provide a venue where the industry at large and all interested parties could come and work together in open source on blockchain-related technologies. Now, at the Fabric level, we have, as I said, we are now supporting running Ethereum virtual machine type of contract on the Fabric network. I think it's really meant for people who actually are working in Ethereum. They already have developed smart contracts they want to use, and they are looking for a different platform because it has some limitations, whatever, and so it makes transition easier. Because there are a lot of aspects to Fabric which you won't have access through this smart contract API, right? Or on the Web3 API, if that's what you're using. We have this Web3 proxy, but you're limited to what's being provided by this API. As soon as you're going to want to use all the specific features to Fabric, then you're going to have to move out of this space. So I wouldn't, it's clear that this is never going to be the primary API to interact with Fabric.
All right, let's meet the speaker again.
Thank you.
Thank you very much for the talk, and also thank you very much for coming. This was the first time that there was a blockchain dev room on FOSDEM. We hope as organizers that you liked it. If you have any suggestions how to do things better, contact us on Facebook or Twitter. And hopefully next year we'll see you again at the next blockchain dev room. Thank you.